This is Fun with Electronics, Project 4, Part 5, where we test each and every one of the circuits that is shown right here. So here we have the first design, the second design, the third design, and Nate's design. So basically for this part, we're just testing each and every one of those. And here are just the circuits drawn here on OneNote. So for design one, I'm using 5k ohm resistor for R, and for C, using a 1 millifarad capacitor or a 1,000 microfarad capacitor to produce a time constant of approximately 5 seconds. For design two, um, I'm using 10 kilo ohm resistor for both of the resistances, for both resistors, and a 220 microfarad capacitor to produce a time constant of approximately 4.4 seconds. So yeah, and for this new design, um, so it says 10 millifarads, but that was a mistake. I'll have that change added to the report, but that's supposed to be 2 millifarads or 2,000 microfarad. And yeah, and for the resistance, I'll be using 100 ohm resistor. And yeah, and the resistance that connects to the from the emitter to ground will be 470 ohms. And for Nate's design will be how you see it. Basically, I'm using for the diode. I'm using a two. I'm sorry. I'll be using a 1N4002 diode. Sorry about that. And yeah, and I'll be using a 2.2 millifarad capacitor. Well, I actually don't. I didn't. I didn't have a 2.2 millifarad single capacitor. So I had to combine some capacitors in order to get that value. So yeah, so here we have let's see a little bit. So I had to combine some capacitors to reach that value. So yep, so I'll explain a bit more when we get to that circuit. But so basically, I have all four circuits on one breadboard, just for more simplicity to make it more compact. Yeah, which is a habit of mine. So right now, so we'll see the first circuit. So here's the first circuit, the second circuit with the blue LED, and here's the third circuit with the green LED, the new design, and here's Nate's design, as you can see over here. So yeah, so we'll test the first circuit real quick, then we'll move on to the next design circuit. Alrighty. So let's turn the battery. Let's connect the battery to the first circuit. Okay. It's connected. The circuit is on. Now let's disconnect the circuit from the power supply. Cool. All right. So for the next circuit, I will be testing circuit number two, design number two. All right. So for this part, here we have two 10 kilo ohm resistors and a 220 microfarad capacitor here, and this whole circuit is design number two. All this. So yeah, we'll see what happens. Let's let's connect the circuit to power. All right. Now let's disconnect it to power. So as you can see, fading is not occurring. There is no fading because I believe the since we have a resistor and a capacitor connected to the base voltage, the capacitor is limited to 0.7 volts, and when the battery is disconnected from the circuit, the capacitor discharges to a voltage less than zero point 0.7. So that's why the LED, both the transistor and the LED, turn off instantly. So yeah. All right, next circuit. So here we have the new. So now here we have the new design over here, and we're gonna test it and see how it behaves. So now when I connect the battery to the circuit, as you can see, the LED's brightness increased for a moment, then it decreased to a fixed value, and now when we disconnect it, it turns off. So basically, it behaves similar to circuit design number 2, and now we're gonna see what's the behavior for Nate's design. So yeah. All right, now last but not least, we're gonna test Nate's design. So where it includes a diode, the LED, and a capacitor and a resistor. So yeah, so for the capacitor, well, ideally it's 2.2 millifarads, but since I couldn't find a value that was approximately 2.2, so I had to combine a few capacitors in order to reach that value. But I'm using I'm using a one millifarad and two 680 microfarad capacitors just to add up to approximately 2.2 millifarad of capacitance. So yeah, so here is a circuit, and I'm using a yellow LED for this last circuit, and here we have the diode, and we're using 470 ohms as a current limiting resistor, just as it is shown, and we'll test and see if it works. All right, let's connect the battery to the circuit. All right, it's on, and now let's disconnect the battery from the circuit and see its behavior. All right, it's fading and fading. All right, there you go. Look at it. Yeah, it's so basically the circuit was successful. So in conclusion, both the first design and Nate's design were successful because they faded away when the battery was disconnected from the circuit. Unlike design 2 and the new design, they basically work the opposite, I believe. And yeah, so the first and the last circuit worked successfully. So yeah.